Hi there, Mr. Sutton here, bringing you the IM3 Honors Chapter 4, Quiz 1, Extra Practice Solutions on Solving Quadratic Equations. To solve this quadratic equation, I notice we have a linear term, so I can't solve it by square rooting. I've got to use factoring or quadratic formula. Either way, let me move everything over to one side. I'll just subtract the 36 to do that. And it looks like this one should be factorable. We have an a value of 1, so I can at least try. Are there factors of negative 36 that add up to 5? Well, let's see here. We've got 1 and 36. No. 2 times 18 doesn't work. 3 and 12 doesn't do it. How about 4 and 9? If I have negative 4 and positive 9, that adds up to 5. So I'll split this up into x minus 4, x plus 9. And now just setting each of these equal to 0 and solving, I see that 4 zeroes out that first parentheses and solves the equation. And for the second parentheses, that gives us an x value of negative 9. To solve this quadratic equation, I notice we've got a linear term, so square rooting is not going to be enough. I need to move everything to one side and use factoring or quadratic formula. Let me get everything on the left side, since at least that would give me a positive squared term. So I'll have a 3x squared that stays over there, and now I'm going to add 36x and add 60, and we have 0 on the other side now. Now, since I don't have an a value of 1, I don't launch right into normal factoring, but let me see if there's a common factor I can take out of this before I use AC method or try the quadratic formula. So it looks like these are all divisible by 3, so let me just factor out a 3. That leaves me with x squared plus 12x plus 20. And now let's see here, numbers that multiply to 20 and add up to 12. Well, how about 2 and 10? So I'll bring down the 3, and I can break this up into x plus 2, x plus 10. Setting each of these equal to 0 and solving, we see that x equals negative 2 and negative 10, and this 3 out in front's a constant, so we don't get any x values out of that. On solving this quadratic, I notice that we have a linear term, so square rooting isn't going to do it. Let me move this 30 over to the left side by subtracting it, and now I can either factor or use quadratic formula. Now, normally I would say quadratic formula, but I want to show you just kind of hard factoring just so you know how to do it every now and then. So if we multiply 5 and negative 30 together, we're going to use the AC method here. That's negative 150. And by the way, you should have already checked for common factors. There's no common factors that we can take out to make our job easier. So it's AC method or quadratic formula. But using AC method, I need factors of negative 150 that add up to negative 19. Okay, well, we got 1 and 150. That won't work. Neither does 2 and 75. 3 and 50 is also a dead end. What else is there? We've got, does 4 go into this? Nope. 5 and 30. Now we're getting closer, but still not going to get a 19 out of those numbers. 6. Does 6 go into 150? It does. 25 times. Well, if we had positive 6 and negative 25, that adds up to negative 19. Okay, well, let's split this up then into plus 6n minus 25n. And let's see here. Let me factor by grouping now that I've got 4 terms. So taking a 5n out of the first two, that leaves me with n minus 5n, so that's nice. And now for the next 2 terms, I can take out a 6, so that leaves me with n minus 5n again. Taking that n minus 5 out of everything, my other factor then is going to be 5n plus 6. And now just setting each of these equal to 0 and solving, for this first parentheses, n must equal 5. And on the second parentheses, we have to subtract 6, divide by 5 to get negative 6 over 5. For this problem, since I just have a squared term and a constant, I can solve by square rooting. Square rooting both sides, on the left I just get b minus 2. On the right side, since I'm square rooting an equation, I have to get a plus or minus. And since there's a negative here that I'm square rooting, I can take that out immediately as an I. So I've got plus or minus I radical positive 36. And now to isolate b, let me add 2 over to the other side. And while I'm at it, I can simplify a little bit more. Square root of 36 is 6. So I can write plus or minus 6i. To solve this equation, we've got a linear term here, so definitely
solving by square rooting won't work. Let me get everything on one side. And I'm not sure I'm going to be able to factor this even when I move this 9x over here, because I'll be looking for factors of 21 that add up to 9, and all we have to work with is 1 and 21 and 3 and 7, so probably I'm doing quadratic formula. So moving everything over to the left side, we've got a 1x squared. I'm just going to write that coefficient to really hammer home the point that I've got a 1 there. So we got minus 9x, and then we still have a minus 21 over there. So again, factoring doesn't actually end up working here, so we go to quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. Plugging in our values, we have an a value of 1, b is negative 9, c is negative 21. Now that we've got these in order here on one side. So we've got negative 9 for that negative b, plus or minus square root of negative 9 squared, minus 4 times the a value 1, times the c value negative 21, all over 2 times the a value 1. Simplifying, this negative 9 is really positive 9. Negative 9 squared is 81 inside that square root. And then, let's see here, we basically have a positive 4 times 21, because those negatives cancel each other. So that's going to be 84 that we are adding, all over 2. 81 plus 84, that's 165. And if you go through your list of perfect squares, none of them go into 165, so this ends up being as simplified as it's going to get. On this equation, we have a linear x value, so that means that I'm going to have to use quadratic formula or factoring. Square rooting is not going to work. So let me just subtract that 63 to get it over on the left side. And now that I've got this in standard form, let me use quadratic formula. I could try factoring this, but I'm not feeling it. Let's just do quadratic formula. So negative b plus or minus square root of b squared minus 4ac all over 2a. And we have a b value, let's see, it's an a value of 2, b is positive 5, c is this negative 63. So plugging things in, that's going to be negative 5 out in front, plus or minus square root of 5 squared, minus 4 times the a value 2, times the c value negative 63, all over 2 times that a value of 2. Simplifying, we still have a negative 5 out there, and 5 squared is 25. And then we've got, let's see here, whatever order you want to multiply these in. Let me just do this on the calculator. So 4 times 2 times 63 comes out to 504. And we're going to be adding that because we have a negative and a negative, 2 negatives. And down below we've got 4. All right, well, 25 plus 504, that's going to be 529. And can I simplify that radical at all? Well, let me use the calculator to see if it's already a perfect square. Let's start there. So checking out the square root of 529, that is, exactly 23. Well, that works out. So we've got negative 5 plus or minus 23 over 4. Well, since we can combine negative 5 and 23, that means we actually have to take this one step further and get the actual answers rather than leaving it in this plus or minus form. So let's do negative 5 plus 23 first. And dividing that, so that's going to be 18 over 4, which I can reduce to 9 over 2. So that's one of my answers. And then we have negative 5 minus 23 over 4. That's negative 28 over 4, which is the other answer of negative 7. To solve this system of equations, I'm going to begin, since y equals this negative 2x minus 12, I'm going to begin by substituting this expression for the y in the other equation. So I can write negative 2x minus 12 equals x squared minus 12x plus 13. And now we only have x's in this equation and can solve for x. Since I've got a linear term here in this quadratic, let me move everything over to one side, and hopefully I can factor it since it's just a 1x squared that we're dealing with. So I'm going to keep that x squared over on the right, and adding 2x over here, negative 12x plus 2x leaves us with negative 10x, and adding 12 over here, we have a 13 already over there, so that's 25 altogether that we end up with. And let me just write the 0 on the right side, because writing 0 equals feels weird to me. So now factoring this, numbers that multiply to 25 and add up to negative 10, that would be negative 5 and negative 5. So let me just write x minus 5 squared equals 0. So then setting that equal to 0, we have x equals 5. Now we just have to plug that back into either of these equations to get a y value that goes with it. Since we're actually finding a point of intersection, I'm going to use this first equation here since there's less going on. So I've got y equals negative 2 times 5 minus 12. That's negative 10 minus 12, so negative 22. So then my answer is the point 5 comma negative 22. To solve this system of equations, let me start by basically setting these expressions equal to each other. Since they both equal y, they both equal each other. So we've got 5x squared plus 2x, basically replacing this y right here. And now that I only have x's, I can solve for x. Since I have linear x values, I'm going to get everything on one side and either factor or use quadratic formula. So let me just move everything over to the left, since that would at least keep my x squared positive. 5x squared minus this 4x squared gives us 1x squared, which is a really good situation to be in. 2x minus this 6x is going to give me negative 4x, and then subtracting 32 gives us 0 on the other side. This looks like I ought to be able to factor it. Let's try it out. We need factors of negative 32 that add up to negative 4. 1 and 32 won't do it, neither will 2 and 16. But 4 and 8 might be a winner. If I have positive 4, negative 8, that adds up to negative 4. So I can split this up into x plus 4, x minus 8. And then setting each of these equal to 0 and solving, we see that x equals negative 4 or 8. Okay, so we have to plug in each of these x values to one of these equations to figure out the y value that goes with each one. So that'll give us 2 points of intersection instead of just having x values. I'm going to use this first equation. It looks nicer to deal with. So let me plug in negative 4 to this one up here. So we have 5 times negative 4 squared plus 2 times negative 4. Negative 4 squared, that's going to be 16. 5 times that is 80. And this is negative 8, so we have 80 minus 8, which is 72. So this is the point, negative 4 comma 72. And then for this other one, I'll just use the same equation. So we're going to have 5 times 8 squared plus 2 times 8. Well, 8 squared is going to be 64. 5 times that is 320. Plus 16 gives us 336. So this is the point 8 comma 336. And those are our 2 answers.